Imagine a world where robots swim through oceans like sharks, insects collaborate like a tiny army, and a soft rubber snake slithers through rubble to save a human life. That world is already here. These are 10 of the most jaw-dropping robotic gadgets ever built, and every single one of them will genuinely blow your mind. Let's start with something unexpected. Imagine you want to become a professional horse racing jockey, but you cannot always jump on a real horse. That is exactly where the Racewood Mark 10 steps in. This is a full racing simulator that feels incredibly real. It has pressure sensors built into the saddle, the reins, and even the whip. Neck sensors track how your body moves while you ride. The machine actually syncs its gait with your rhythm, so if you speed up or lean differently, it responds. It connects to ANT Plus for live heart rate monitoring, and a screen in front of you shows real-time feedback on your balance and technique. At around $55,000, it is clearly built for serious professionals, but the training value is absolutely enormous. Jockeys use this machine to sharpen their skills without putting a real horse at risk. Now let us take to the skies, because the BionicSwift from Festo is one of the most beautiful robotic creations ever made. It looks and flies just like a real bird. Its feathers are made from ultralight foam, each one mounted on a tiny carbon fiber pin. During the upstroke, the feathers fan out and let air pass through. During the downstroke, they fold tight and push the bird forward. What makes it extraordinary is that it navigates entire rooms on its own using radio modules instead of cameras. No GPS, no visual tracking system, just radio signals and clever engineering. Watch a flock of BionicSwifts in flight and you genuinely forget they are machines. They are graceful, precise, and surprisingly emotional to watch. From the sky, we head into disaster zones. CHIMP is Carnegie Mellon's answer to one of robotics' biggest challenges. How do you send a robot into a dangerous, unpredictable environment? CHIMP moves on all fours like an ape, but it can also stand upright when the task demands it. It has rubberized tracks on all four limbs, which help it grip and climb across debris-covered terrain. Its hands have opposable thumbs, meaning it can turn valves, pick up tools, and even climb walls. Think about a collapsed building, a flooded facility, or a chemical plant after an explosion. That is where CHIMP earns its keep. It does not replace human courage, but it protects human lives by going in first. Moving on to something smaller but equally impressive, Hexa by Vincross looks like a mechanical spider, but it is so much more than that. 6 legs, all-terrain movement, and a brain powered by the Mind operating system, which is built on Linux. Hexa uses its onboard camera and sensors to observe its environment and actually learn from it in real time. What is really fun is that it comes with a dedicated app store where developers and hobbyists share their own Hexa projects. You can turn it into a security patrol bot, a plant mover that follows sunlight, or even a dancing companion. It is a small robot with an enormous creative ceiling, and that is exactly what makes it so exciting. Now picture dozens of robots no bigger than your hand working together silently and perfectly. That is the Bionic Ants from Festo. Each one is just 13.5 centimeters long, fitted with tiny cameras, infrared sensors, and powerful mechanical jaws. But the most remarkable thing is their teamwork. These ants communicate with each other and coordinate tasks without any central controller. They move objects together, plan routes together, and share goals together. When their batteries run low, they simply walk to a charging station and refuel through their antennae. Watching them operate is like watching a tiny civilization in action. Festo built them to explore how future factory robots might cooperate without needing constant human instruction. Staying in the world of biomimicry, let us talk about the Boss Robotic Stingray. Developed with German government support, this machine was built for underwater reconnaissance. It glides through the ocean like a real stingray, moving with incredible precision just 20 centimeters above the seafloor. Inside that streamlined body you have sonar, cameras, and even a water sampling mechanism. It can scout underwater environments, map the terrain, and collect data with a level of stealth that traditional underwater vehicles simply cannot match. For marine researchers and defense applications alike, this kind of natural movement means less noise, less disturbance, and more information gathered safely. Speaking of underwater robots, here is one with a very different agenda. The Robo Shark is a 2.2 meter, 75 kilogram surveillance machine used by the Chinese military. It swims at 18.5 kilometers per hour using a tail propulsion system, which makes it almost completely silent in the water. It can operate fully autonomously or be controlled remotely from up to 3 kilometers away. Unlike traditional underwater drones that hum and whir, the Robo Shark slips through the ocean without a sound. That quiet, combined with its shark-like appearance, makes it one of the most serious and capable surveillance tools currently in the water anywhere on Earth. Now back to the surface, for something genuinely adorable. Hangbot Sirius is an AI-powered robotic dog that weighs just 1 kilogram and starts at $659. It runs, jumps, and learns movement patterns just like a real dog would. But the truly special part is that it integrates with OpenAI to actually develop its own personality over time. You can control it with your smartphone, a game controller, or even smart glasses. The more you interact with Sirius, the more it adapts to you. It is a pet, a companion, and a developer's playground, all packed into a lightweight aluminum frame that fits in your bag. Then there is something that sounds like science fiction but is completely real. Octobot is a soft-bodied robot with 0 rigid parts, 0 batteries, and 0 electronics. It moves because of a chemical reaction between hydrogen peroxide and a platinum catalyst inside its body. That reaction produces gas, which flows through channels and inflates the arms, creating movement. The whole thing is built using 3D printing, soft lithography, and molding. Its timing and rhythm are controlled by a soft analog of an electronic oscillator. It is delicate, it is slow, but it is a genuine breakthrough in proving that robots do not need hard shells or power cables to function. Finally, meet Roboa, a pneumatic rescue robot that grows. It starts compact and literally expands forward, slithering like a snake through rubble, tight pipes, and crushed spaces where nothing else can fit. It can expand and contract its diameter between 5 and 10 centimeters, depending on the gap it needs to navigate. Inside, it carries sensors, audio systems for two-way communication with trapped victims, and even supplies like water or medicine. It is soft, so it is safe around fragile survivors. ETH Zurich built it with one purpose: getting there when humans cannot. These 10 robots are not future dreams. They are present reality. And honestly, they are just the beginning.